Why don't we get going then? So just wanted to look today, guys. I think we understand there's an issue with the soil conditions at the police station, the public safety building, both at the proposed new entrance, the vestibule, at the three-story addition we're going to put on, and at the back of the building where we're adding to the sally port. So Power did go out there. They did some borings. We got the report. We got the narrative on that. But it's obviously that there's some issues we need to deal with here. It's a confined site. We have to get to a bearing place where we can support the building and the additions. So we wanted to look at the different options given the constraints of the site. Given the schedule, given the proposed costs of some of the options. And I think we need to work together as a team to come up with the best solution to move forward for the project. So with that, Janet or Simon, maybe you can just give us an overview of what you found in your report. We've all read it. I know you proposed some deep foundations. We're perhaps going to look at some mini piles or some sort of helical pile as an alternate, but maybe you can just give us an overview of your thoughts on the soil conditions and what we need to do here.
So I'm going to give it to Simon and let him dive in, and I'll let Wesley join in as he sees appropriate. And I'm going to sit back here as the architect, not the geotechnical engineer. So, okay. I do have some images, Simon, if you need me to go to the images.
I was just going to ask you if you've got the slide deck. I'd appreciate that.
I have a can you make me a co-presenter or something?
There you go.
Okay. Can you see my slide? Can you see?
Not yet.
Not yet.
You're not sharing.
Not yet. No. Hold on. Let me see. There it is. Should be coming.
Yep, we got it now.
Okay, I'm going to make it bigger so I can come in on closer on things. So obviously, these are the areas of the Union Street entry. So the new building is going there. Just obviously everybody knows this, but I'm going to point it out. The new entry is here, and then we'll be filling in this entry at this point. So that's important. And then back here where the Sally Port is. So there you go. Simon, you want to start with that?
Yeah, thank you. Thanks. First of all, let me say to everybody, I'm probably going to be using terms that not everybody is familiar with. So if I say something that is not clear, or I'm using jargon, then please stop me and ask. Just to summarize what we found in the investigation, and Shane, I think you wanted to focus on the three-story addition area first. Okay. We did find in boring 2, which is down on the bottom left of the plan, yep, that, and if we can just go to the next slide, Janet, please.
Okay. Hold on.
Well, actually, boring 2, if you can.
Boring 2, yep.
Yes, please.
You want me to get that larger for you?
If everybody can read it.
I don't know. That better?
That should be good.
Okay.
So the ground elevation here is about 100 feet, and the finished floor elevation of the existing basement elevation is about 95 feet, which is about 5 feet below ground level. So about 5 feet down on this boring log. Now, as you can see, that is in fill material, which is unsuitable as a bearing medium for foundations. And as you can probably see, down about 9 to 9.5 feet, we found a organic silt, which is very unsuitable. It's weak, compressible, unsuitable for bearing on for foundations. So what we suggested in the geotechnical report was to excavate to finished floor elevation, which is about 5 feet down, and then excavate a further 5 feet, but down to the glacial till material, which is a good bearing medium. The issues with that is that the existing structure, the existing building would need to be underpinned and supported. It is possible, however, that the building foundations go down that deep anyways. The other issue with digging down to that glacial till material is that we will be excavating about 2 feet below observed groundwater. So there is the other issue I should mention is that because we're digging down, of course, we would need support of excavation to hold up the ground around the excavation. The further issue is that we've only looked in one location, up close to the northern end of the proposed addition. We don't know exactly how this organic material and the fill is going to be present further south. It's possible that it goes deeper, we just don't know. So that was one option that we looked at. The other option that's been brought up, I think, by Bond, and we also considered between PAR and HKT, was a pile foundation solution. And that also has its own issues because usually the pile solution is more expensive because of the mobilization costs and just additional costs from bringing the equipment on site. The other issue is that the equipment will be difficult to get close to the existing building, and it will have to be brought into the area will have to be brought down to about elevation 95, which is about 5 feet below ground level, and the equipment brought in and the piles drilled into place. So schedule-wise, probably the pile foundations will give the least amount of risk, but probably at additional cost. So there's pros and cons to both methods. So any questions up to now?
The first set of sorry, this is Phil Renzi. The first you were discussing was the helical option, and then the second was the pile, correct? Or what?
The first option was to just excavate down to the just excavate and do a conventional spread footing.
Did you mention the helical? Is helical and the piles similar pluses and minuses?
Yeah, they're two different piles, but they are basically the same.
Okay, thanks.
Sure.
Simon, question from Bond. You had mentioned the cost comparison.
Yeah.
We agreed 100% with all of the things that you mentioned with respect to underpinning, SOE, dewatering.
Yeah.
But and we'll sort of show this out. But I'm curious what, and you suggested that the pile pier system might be more expensive. Did you account for the cost of underpinning and SOE and dewatering, especially dewatering into frac tanks, because there's no place to put that water? We're finding it very surprising that you would think that was a less expensive, the existing system that's currently shown was less expensive.
My experience is that I find pile foundations very expensive. So usually any other method is cheaper. But okay. I'll be guided by you. If you've got more experience, I'll be guided.
No, it's absolutely true that the piles in and of themselves, if you take only the piles in context compared with an over excavation and replacement of material, is more expensive. But when you consider that you'd have to put in essentially pile-like elements for the support of excavation and underpinning pits specifically down to support the structural, and then compare them against the cost of the over excavation and the dewatering that Dave's talking, the drilled mini piles working from the existing surface or a bench are going to be considerably cheaper. Pricing that we got to do the underpinning pinning alone could be as expensive as the piles in total before you even excavate.
Okay, I take your point. One small issue with that is that I think that the excavation will be needed anyway to get down to finished floor elevation. So an excavation to 5 feet below ground will be needed in any case, and in which case you'll still need support of excavation. And I assumed that the contractor would use sheet piles to support the ground, and in which case he could use a crane or a track hoe or similar to vibrate the sheet piles into the ground.
Right. So the an alternative method for providing some of the supportive excavation is to actually drill some additional steel pipe piles that wouldn't have to have the bearing, but would have be used for cantilever. We could weld some clip and lagging to those. And as we would try to maintain a level above the water table, that we could use wood lagging so that we wouldn't have any flowing conditions where we might have to get cut off below those elevations.
Yeah, no issues with that. And what I
So
was
we
also
could use
thinking,
the same drilled mini pile rig to put in some additional pins, if you will, around the perimeter that could support the lagging. So in essence, as you pointed out in your introduction comments, there the costs of mobilization. We're trying to get efficiencies out of the piece of equipment that can propose a solution that can all be executed with a single piece of equipment or a single piece of equipment type.
Yeah, I take your point about that also, because the same foundation drill rig actually could be used on the entry and at the sally port.
And in our intention, I did have I shared out some of the information on this and had some extensive conversations with Keller, and who can provide a variety of foundation options here. And part of their concern was that the lower capacity of a helical screw and the potential even around the front entry where some of the construction debris was found, that we might have,
it would hold up on it.
Right. And then even just being able to put down enough of the screws and at the depth that they would need to be might be more troublesome than just running with a higher capacity drilled mini pile. Try and stay under or design it around, say, roughly a 35-ton capacity, so that we can avoid the need for a load test and the additional expense of a load test.
Yeah, because I would also, this is Wesley speaking for structural, I would also say that for some of the interior column footings, you would probably need quite a few helical piles to take that amount of load. So I don't think that helical piles will be able to take 3 stories worth of capacity coming down.
Agreed. They're likely more like a 7-ton capacity unit.
So
The
it
other
sounds
piece
like
of
the helical
information
will not
is
work
that-
on this, but the mini piles would be an option.
I'm sorry, Shane, I didn't get all
So it
that.
sounds like the helical piles are not an option here, but the mini piles are an option.
Correct.
As was mentioned, the helical piles, because they're just like basically a household wood screw, there's a potential for those to hold up to encounter perhaps a cobble or a boulder or a piece of concrete, something like that. Once they hit that, then they won't rotate any further. They'll just stop. Whereas a mini pile will, because it's more like a a rock bit, a rock drill, it will drill through that.
Mhm. Okay.
So there's
And
more reliability in a mini pile.
the getting the drill rig down to, I think you said 95
Hmm.
feet. So maybe this is more of a question for David or Greg. Does the pile rig have the reach to get over there where we have the isolated footings, or do we need to drop it in a hole?
The rig wouldn't have to go down that far.
Right.
We
Okay.
could bench it level and work from a grade of roughly around 100, or perhaps sumps down a little bit for access for the spoils that would be coming up with the drilling operation, and then grout to a certain height or cut off the pile as we excavate down to the bottom of footing, plus whatever required embedment depth we would have in the footings.
And Keller has some pretty small equipment. We've actually done these inside existing buildings with a 10-foot clearance overhead.
Mhm.
I don't think access is going to be a problem.
Yeah, to put down a 35-ton could be a low overhead unit and a basically the same kind of a boring rig that probably did some of your test bores.
Yeah.
Would be capable of putting down some 5-inch or 6-inch diameter drilled mini piles.
Yeah. My
The,
concern was actually getting the rig close up to the existing building. Are they confident that they can do that?
Well, I think we can work with the structural for whatever that setback is for the mast or the front of the rig, and then size the footing, the interior footings appropriately for locating the column with whether it's a little cantilever. And then we also do have the opportunity to engage the structural slab in there to really create a total load distribution solution for the footings incorporating the slab. And
that's actually another point I was going to bring up. If we do go with the mini pile option, you are supporting an additional floor's worth of load, because if we go and do the excavation option, then you would be, the slab on grade would not be loading any of your foundations. Whereas once you turn this into a pile, a mini pile, and pile cap and grade beams, you would be taking the load of the basement and putting it down into your piles as well. So that's something just to be aware of, is that the loads are going to be bigger because you're picking up an additional floors.
Sure.
And then there's also 35 tons then and require load testing.
I think we would just use more piles.
More piles.
The appropriate amount of piles, analyze the specific loads, and then use an appropriate number of piles.
Yeah. I mean, if you say that 35 tons is about our limit, then we can use that number to estimate how many piles we need. So.
And then also figured that there's a diversity factor that you wouldn't put only a single, even if it was only 35 tons of load, you wouldn't put a single pile under a cap. Sure.
Yep. And then also the other question is what's the spacing that we can put these mini piles at? Because we want to space these out so that they don't interfere with each other. So.
Sure.
Yeah.
It's usually twice the diameter.
Twice the diameter.
Distance, yeah, between each of them.
Has a clear distance between them.
That's great.
So this is Phil Renzi again. How quickly can that be looked at to make sure that that's even an option? Because what it is limited, this isn't a huge addition. I assume these aren't going in the existing building, just the new building, these mini piles. But to run that, what you said about the running the number of piles and their distance, right? Like that needs to be figured out almost immediately, I guess.
the
To
foundation
figure out,
firm.
yeah, 'cause
that I-
you're saying it has to carry 35 tons, right? Like to make sure that you have enough room for piles to carry 35 tons. Do you feel
No, they were
confident?
actually, they were making the recommendation to cap the capacity at 35 tons to avoid the need for a load test. Because if we have to do a load test schedule and testing and whatever else, we're spending an extra $40,000 for proof of concept, where it won't be required if we stay under the 40 tons. We did some preliminary and capacity evaluation with one of the foundation contractors, and seemed to think that 17 to 20 piles would be, likely underneath the 8 footings, and then some additionals underneath the foundation wall. But I think we have also, I'd like to suggest, using the bridging of our 12-foot deep cast in place foundation wall to help with some of the distributed load along the 72 feet or so of the front of the building, because that in essence acts like a large
beam. Yeah, it's a very deep grade.
beam.
But yeah.
Right.
I mean, we can always design the rebar to help it spread out the load. Yeah.
Absolutely. Since we're going to be putting, if we're now looking at more of what I would consider a point load solution rather than the bearing capacity of the soil, then you could factor that into account,
Yeah.
dealing with the wall and taking advantage of the fact that we're building it anyway.
Yeah, I mean, if that's the case, yes. The only thing is, if there's any type of if we're using the walls to retain any soil, right? For any type of overturning, the mini piles won't really help you much with retaining unless it goes high enough up into the grade beam.
True. So prior to backfill, whether that might mean some moment or some framing in the steel.
Exactly.
To act as a strut, because I know we want to remain separate and not count on any thrust or capacity imposed against the existing building.
Yeah, because if you have one row of piles, obviously that wouldn't give you any rotational resistance. So.
Right, but if we were going to incorporate a structural mat,
Yep.
thickening of the mat and putting enough rebar in there to design it
Yes,
to
and that
use
will-
the depth that's the 15 feet or so of the structural mat as a toe for overturn
Sure.
of the foundation walls.
Quite a bit, yeah. Yep. What I think is going to be limiting is probably going to be those interior footings where we have to cantilever out. So because the cantilever is going to attract a lot of the loads. So
Sure.
Yeah.
But those could be thickened grade beams that, or, incorporated in the slab back
Sure,
out to the wall.
my guess is the pile cap basically is going to be a turn down of the slab. It's
Yep.
going to be a turn down of the slab that all these mini piles are going to stick up into.
And then I don't know if anybody wants to rely on any capacity for the existing foundations or coordinating with those that are around the projection of that center doorway, or whether we're just yanking them out and starting clean, and because we won't have any proven understanding of what those might contribute, if anything, other than as an obstruction to the work that was done in 2001.
Yeah, I mean, we don't know what the load we can put on those are. So
No, that's correct.
yeah. And we don't know whether they excavated the organics that's underneath those footings either. So
Right. I was just perusing through the 2001 drawings to try and deduce whether they'd made any effort, but again, that's what was documented, not necessarily what was executed.
Yeah, I'll agree with that. The plans that we have are construction drawings, they're not as built.
Okay, so it sounds like we may be leaning towards these mini piles. So have you guys, Greg, started to, I think we'd still like to just do the price comparison. So were you guys doing that part as the estimate for the schematic?
Yes.
Yes.
It sounds like Wesley and Simon, it can go either way structurally. Either one will work.
Yeah.
And we should work with Bond to look at what the best solution cost-wise and schedule-wise might be. But
Yeah, Shane, just to be clear, we're pricing it as designed as our base price, and then we'll have an alternate, which I'm deducing will probably be a deduct alternate based on, we've spent some time costing the base price with all the methods and SOE and underpinning, and we've got some good subcontractor feedback on all that. So we believe it'll be a cost savings. We're still pricing the alternate system out based on this conversation, but we will have a VE essentially to change the system though.
yeah, I think to reconcile with Jerry Tortora, that's the right way to do it. And as part of that reconciliation, we'll just, you have to see what Jerry included for excavation support, dewatering, and all of that sort of stuff too. I'm not sure
Based on
what
the
he'll
previous
capture.
documentation on costs, we believe, depending on where the estimate is now, that this could be, regardless of what system, there could be some stuff that wasn't accounted for with SOE and underpinning based on what we've seen. But
Yeah, I've gone back and looked at it. Yeah, it's there wasn't a lot in the previous estimate. I think 20,000 for underpinning.
Can I ask a question? Is there anything about the utilities that adds any, I want to just flip ahead to the images you guys sent. Is there anything with the utilities that makes either of the options any better? I assume we still have to excavate, move things, but could you comment on that from Bond's perspective? Yep.
Sure, that's a great point. I think the idea of using a drilled element for what we might need to do to thread in the supportive excavation will help with maintaining or minimizing what we have to do in the utility corridor outside of the foundation for passing by to install the new storm and deal with the sanitary tie-ins out. So we need to consider installation of new structures for the storm bypass, as well as protection of the existing structures that we'll be tying into for the sanitary, and minimizing the amount of disruption out into the parking lot.
Okay. So that existing sanitary that's shown by that orange bar, just for those who haven't looked at this a few times, are you suggesting that could stay in place and the piles be pushed around it, or
No.
or no? Okay, just
No,
wanted to make sure.
Not any of the sanitary that's inside the footprint of the new building, because that's probably in PVC plastic.
Okay,
And
just wanted to
since
make
it's
sure.
going to go under the building, it'll have to change to cast iron.
Okay, yeah, just wanted to make sure. I wasn't, when I was
But
looking at this,
it would minimize on potentially some temporary condition solution. If it was a pump or something, we could leave it in place longer.
Okay.
But in the end, it's to Greg's point, the material will probably have to change regardless.
Okay.
We also looked at on the that new storm that would probably want to go on the opposite side of the SOE under the.
I wondered that myself. You'd seen the angle proposed, so it would be on the other side of it. Yeah. Okay. Yeah.
Which currently it's currently shown closer to the excavation regardless, so that wouldn't work in its current location in either scenario.
Okay. Yep.
Can I ask a term question? I know SOE on my cars is my standard operating equipment. What's SOE in structural? What's SOE in structural world?
Support of excavation.
Okay, great. I was trying to figure it out and I couldn't. Thank you.
We also have electric in the front of the building for those street lights, which I assume they're on the town's grid. It's not coming out of the public safety building. So we just need to be careful with that too. You got those 3 or 4 light poles in front of the building.
Yep. I think there's going to be, all the utilities are going to have to move, and we anticipated that, I think, in the schematic design. I have it on here, but that there was an anticipation all that was going to have to move. I guess the question is, how far does it have to move? Is there an advantage to this pile world to limit how far out you're going into the site or anything like that? I guess I was asking that question as well. But, we can figure that out later, I suppose.
Yeah, and again, we think where the solution at the new vestibule was already a pile solution, you're gonna have a rig out, the immobilization costs will be spread out now. We probably should spend a minute talking about the Sallyport addition, so before we break. But we can keep this for now.
Well, just before we do that, so we had talked about, maybe doing some more investigative work out there, a couple of pits or something. Is there any advantage to doing that now? We only have that one boring in the area.
I guess the one thing that I was sort of surprised about was the discussion that took place about how deep the existing foundation goes. And is it, in terms of defining the underpinning, if we needed to determine that, I mean, if we're leaning on the pile solution, it probably doesn't matter, but that would be the only reason I would think to go with that.
Well,
Go ahead, Simon. Simon, go ahead.
Okay, thank you. I thought somebody else was going to speak.
No, jump in.
If we can go back to the site plan that shows the boring locations, please. You see there's test pit 4 that's at the bottom left of the drawing. Fail test pits.
Oh, the test pit 4, where is that? Oh, right here.
Yeah.
There it is.
Now, unfortunately, I can't share it with you, but I have a plan. I have a PDF that shows that. I apologize.
So what Simon's getting this up, those are the borings from both the 1999 and the 2021 overlaid. So the ones that we've done just now are the B21A and 1, 2, and 3, just so you know. And the other ones were done for the 1999. So for Phil and the rest of you guys, that's what we're looking at here. Okay.
So I have a plan from the McPhail investigation back in '99 that shows in test pit 4 that the bottom of the foundation is about 14.3 feet below ground surface, which they quote as being 106.4 feet.
Simon, can I ask a question? When you're looking at their numbers there for the test before, is that reconciling the differences in elevations that we talked about earlier? No.
It is not, and that's why I say that's what they quote, 106.4.
Yeah, so can you explain to everybody what that differential is between the survey numbers and the as-built, or the potential for that we kind of looked at? So.
Yeah, you'll have to remind me, isn't there a difference in data?
Well, remember, the original data point, was a little bit different than it was 20 years ago. And I think we had to look at that again based on the current survey we had and the numbers they used. So it was a little different, right? Is that still the case? Yeah. So.
Yeah, it is. It is. I would have to calculate that, what it is in today's datum or the comparable datum.
Yeah.
Just so everybody knows. We were going to test the foundation wall for asbestos in that area anyway, right?
Well, at some point we're going to, he made the assumption in this, which is in this area right here, that where we're breaking through to get into the lowest level, that there might be asbestos on that wall.
Right. So if we're going to have an excavator out there to excavate down to check the wall, we can just, keep going and see how far that maybe is actually.
That's possible. Yep.
So maybe we can do those two things at the same time.
Yeah, I mean, the question I think, Shane, you're asking is whether it's worth it to do a test pit or test pits right now, and what would they be the implications of doing those right now? Is it worth it, Simon and Wesley? Is it more information? Does it become a challenge with how close that area is to, you know, like here's the, just so you know, here's the parking and here's the building. So we're trying to excavate in a very narrow slot of space. Is there, would that gain anything, Simon, I guess?
I was also gonna mention that there's underground utilities, of course, which we know
Yeah.
about. So it
Yeah.
feels like we're threading the needle.
Yeah.
Right.
Yeah.
With a
We'd
test pit.
we'd only be super concerned about it if we were staying with the conventional
Alright.
foundation system.
The over excavation,
Mhm.
yeah. Okay,
Agreed.
Yeah. Okay. Okay. All right.
all right. So do we need to talk about the
Yeah.
the existing entranceway?
Well, the
and-
existing, yeah, we should just, let's just, you know, make sure we look at all of them. There's the existing entry that's, or the existing entry under the curve. And Wesley and Simon, we have talked about that, as well as the new entry. Those were all on caissons originally, correct? Is that correct?
Yes.
So where we're infilling the existing entryway,
Right here.
yeah. Do we need some sort of piling system there? How is that infill supported?
So probably,
Yeah.
so we're probably gonna need to create a new slab for that new infill to go to rest on, basically. And
Mhm.
that will basically be its own mini pile supported mat, so.
Yeah, and I was interested in listening about the 10 feet that's needed. Wesley and
4 feet.
Simon, would that change how you get those piles in? Because we had talked about pulling them forward of the building, cantilevering, right, with the slab.
Yeah, agreed. But if Cala have a low access, low headroom drill rig that they can get the mini piles inside the existing entryway, then they could use that.
Right.
Just something else to be aware of for the existing entry is that there's records that is supported on caissons. So just have to be aware of that when they're drilling the mini piles.
Okay. Anybody else? Is there anything else on the entry points that we should talk about, or should I move this image back here? So, Wesley, you have anything
just,
else?
David, we look to do everything on the front of the building at the same time, just to sort of utilize the rig when it's there and the mobilization.
To the greatest extent possible,
Yeah,
yes.
I think that was sort of the intention too, right? That we would start the lobby and the 3-story addition at the same time.
Oh, yeah.
Yep.
Yeah. That absolutely makes sense to do that. Yeah.
Just curious, what are you carrying for a cost per pile?
I think it, Greg, do you want to, I'm trying to recall, was it 6,500 or 7,500? Greg's muted, he may be en route. I was just looking at
Obviously,
this
there's gonna be
one.
more economy if you do a lot of them all at once,
Mhm.
so.
Yes. We can come back to, I'll get that for you. We just looked at it this morning. I just, I'm having a tough, I think it was either 65 or 75 a pile, but I could be wrong.
Is there any, is just curious, and this is, you know, this is totally a construction means method question, but is there any advantage to even doing the ones at the Sally Port and capping it and waiting until that gets done, or doing that simultaneously just to, and there's no dewatering up there, correct, Simon, up at the,
No, yeah, no dewatering.
yeah,
The issue, yeah,
Not the
we
Sally
can,
Port.
we can definitely look at that, you know, in terms of just putting the piles in and then waiting to come back around there and see if it's cost effective.
I don't
The
know.
issue
I
up there
just,
on obviously the issue up there is the electrical, the existing electrical navigating around that.
I guess the big question is with all the utilities is, you know, what's the plan for moving the utilities so that is it still a 24/7 building, no downtime? You know, what's the plan for that? As opposed to, is it, you know, is it worth it stopping and starting? It's just my question. So, okay.
At the Sally Port.
Mm-hmm. Yeah.
I think that there's a solution that can be developed at the Sally Port that we bridge over the duck bank and looking at, I think from the boring information and from just the logistics, now understanding how much cover or where the logical bottom is of the duck bank, I think that we may be able to over excavation and backfill, but more as like a linear footing across the face of it, and then maybe try and tie back some grade beams over the top of the duck bank back into the building. If we could utilize that foundation wall of the existing garage.
Well, the existing, I think, is also on caisson, so we don't want to be
Right.
loading more onto the caisson than we know about, so.
Well, there's not that much of a load. I suppose that if the requirement was such that we would have to put in a parallel frost wall to support the slab
I mean,
at the face of wall, or could we just reinforce the structure and support it on three sides?
in terms of the proposed structure that's on mini piles.
For the Sallyport addition.
Yeah, the Sallyport addition would be its own slab on mini piles and grade beams.
If the conservative approach there would be, yes, install drilled mini piles in the in that location.
Yeah.
The question is, could we, because of the better soil up there, because of the significant amount of over excavation and material that was taken out from the old police station, as well as for the excavation of the garage, could we improve the material up there with a traditional bearing footing? You know,
I think that was
enough
one
that
of
it's not imposing any load on the existing foundation, but the duck bank seems to be about.
You're cutting out, Greg.
Yeah. Good, it's not me. It's yeah. Okay.
I think in any scenario, we just want to make sure that the solution bridges over the existing duck bank. And whatever the most economical way to do that is, you know, we obviously just have to leave it in place and bridge over it.
I think Simon and Wesley, we talked about you could do either one successfully up there. So,
Yeah.
you know, okay.
And Greg,
Yeah.
I don't know if you can hear us, if you're back on or off, but I couldn't remember off the top of my head. There was a question about cost per pile, and we looked at it this morning, and I was struggling to recollect what that was.
It's about 6,800, 7,000 a pile.
Yeah, so that's what I recall, but it's.
But the comment that I heard, or to comment on the concern of multiple phases, yes, we would want to try and get all the foundation elements in one mobilization, whether we did the excavation in those locations or not, or whether it was just a temporary location and we covered them up and then, you know, went after the foundations of the Sallyport later on.
I would like, can I just ask if Chief Scory or Lieutenant Chief or Lieutenants here or Deputy Chief, anybody comment on the impact of actually going at the project from all three entry points at the same time? Is there any issue with you guys with that?
No, I don't think so.
Yeah.
Whatever we can do to expedite the whole project, I think is beneficial.
Okay. Okay. Good to know. It does give bonds something else to think about, you know, as far as, you know, do they go in and do the foundations and then cover it up, or do they start building at that point, you know, and, you know, it's sort of a means and methods decision. But that's certainly possible. So, okay. Thank you. So do we, no, I'm just jumping in here, random questions. Do we wait until Monday and I think it's a wise thing to do, to wait to see the estimate, to, you know, make any of these final decisions on whether, it sounds like we're going to piles out front for many reasons. Everybody is okay with that. The one in the back is possible for either. Does that make a difference? to the cost at all, whether it's conventional or piles. And then we'll, explore it during the estimate process.
Yeah, I agree. I think we want to wait to get the cost back. We'll look at the, whatever way Bond does as an add alternate or deduct alternate, whatever they're going to do, just to weigh it up. And then David and Greg, yeah, I mean, the mobilization at the back, whether we do that at the same time or whether we go back to the conventional, I'll leave that up to you guys. But certainly, I think piling is the way to go with the front of the building, given the constraints, given what's there with utilities, and then just the risk of over excavation, not knowing where you might have to go with that. We're saying 10 feet now, but that may turn into 15 feet when we actually start doing it. And
sure, absolutely.
It's possible.
I think that's a big risk to.
And where that extra footage could be in the water, certainly doesn't make it anywhere near less or more palatable. Obviously we want to avoid that at all costs.
Okay, makes sense. So, and especially, I mean, trying to wear the hat of making this building the least costly project for the town because of our limited budget. I'm all in favor of the lovely words I heard from you that will be a deduct.
Well, it's a deduct compared to what's currently drawn.
Compared to, yes, no.
We don't think the current estimate includes what's necessary to build what's currently drawn.
Yeah, because of course no one knew that,
Right.
back at when.
So it'll be a deduct in concept, but unfortunately, I think it's driving regardless, getting out of the ground is going to be more expensive than originally contemplated.
Yep. Well, that's not a surprise. So, okay. Shane?
No, I think that's what we wanted to sort of everybody get on the same page of the geotech engineers, the structural and the construction managers sort of, get around the same table or on the same Zoom meeting, if you like, to just to come to a consensus that what the options are. We'll price them. We'll come back next week after we present them to the building committee. But I think this was a good meeting just to get everybody on the same page.
Absolutely.
Yep.
Shane, will someone or you or the structurals provide some simple simpler kind of matrix comparison of these options and prices, pros, cons when you do present it baback to the full committee?
I think we can do that, Phil. Yeah.
It might help, I think, get this conversation through, a little easier if we had a simple document like that.
And we want to make it as easy for them as possible. Otherwise, we'll go down a rat hole with this.
Sure. Yeah, I mean, I think, at the committee level, it'll probably come down to schedule and cost, right? Our engineers can design any system you want, and our contractors can install any system you want, but we just want to make sure that it works financially and schedule wise. So we can put something together and it'll show that.
Yeah, I agree. And the only thing I'll mention, and I don't think, is there any similarity to what happened at the Galvin? And we have both Bond and Left Field. I wasn't part of that project, but I know there was some returns regarding some of the structural somethings, but sounds like it's just a totally different earth.
It's totally different. Those were we had two different types of piers at Galvin. They were grouted and ungrouted. And the design was for ungrouted at the slab and grouted at the structural elements, and the ungrouted were not sufficient, but the grouted were. So we wouldn't have an ungrouted pier condition at this anyway. So
got it. Okay, just thought I'd ask that because that may come up at the PBC as well. So
yeah, we were anticipating that question.
Yeah. Thanks.
Yeah, if you found something, if you guys from Bond know something about the soils out there that you could share, please share. If something happened, I mean, not that the Gavin, it's not that far away, but it could be a completely different soil conditions. But if there's anything let us know. So
it was just a pocket of heavy organics that caused some issues.
Okay. All right.
All right. Is there anything else that you need, Dave or Greg, from the engineers, or have you got enough information to, you know, put a
I mean,
decent,
we took a
proposal
pass
together.
at the costs. I think it would be, you know, based on the criteria we talked about with the number of piles, that would be the only thing that would vary a bit, you know, so if there was
Piles
some,
how many piles did you carry with, when you estimated this?
Two per cap and an additional 2 underneath the foundation wall.
2 per pile cap and 2 under the foundation, basically a mid-span between the pile.
Yes,
Mid-span.
on that long span of the wall there.
Okay.
so if that went up or down significantly from what we guesstimated, then that would drive the pile number up or down a bit, but
Sure. I think in general, just on the cantilevered ones, anything that's cantilevered, you might want to add another pile in there.
yeah, I would
For
take
the 2 interior footings.
Yeah, exactly. The interior ones, you should add an additional pile.
Okay.
Yep.
So yeah, if there's if your calculation, as you mentioned, needs to accommodate now 3 levels in there, including
Yeah, because it takes the ground floor slab as well now, so.
right.
So it's 4. It's at 4 now, Leslie?
Let me do a quick estimate real quick.
Sure. I mean, you can follow that up in an email. We
Yeah.
don't have to put you on the spot for
Sure,
and
yeah,
hold you to a calculation, but it'll just inform the number of units that we carry for the evaluation.
yes. And like also remember that the slab needs to be a lot thicker, so you have to carry more concrete for the ground floor slab.
Sure. Well, the toe on the ground floor footing so if the footing and slab is more monolithic now, and then by the time you looked at what was in the original design for
Yep.
The size of footings and 2 foot thick, if there's really probably not that much more additional concrete if it's all a monolithic pour rather than
Yeah,
footings
I
and
agree.
slab.
We're just gonna do a monolithic, basically a mat that goes across.
Yep.
With like a haunch turn down wherever we need a grade beam or anything like that.
Right. And then, so it's just really, I think that the difference is how much rebar you think we need to add in that.
I think in terms of rebar, I think a good estimate, just off the top of my head, would be probably number 6 is at 12 each way.
Okay. So about 22, 24 pounds a square foot.
Plus whatever additional is needed right where the column comes down.
Sure. Okay.
Yep.
okay.
we'll have what we need and we'll be ready to present it.
Okay, great. I don't have anything else then. I think this again was a very good meeting. We can move forward and make an informed decision as a team. Janet, your team, do you have anything else you need or?
No, I think, you know, with the estimate coming in, you know, tomorrow or whatever, Friday, you know, there's, you know, I think Jerry Tortora will be estimating when he sees on the drawings, he won't have any information on piles. So,
Right.
you know, it's just going to be for him, you know, to confirm, you know, I guess, Dave, you know, what were you carrying? You were carrying for the standard foundation, what were you carrying as far as, you know, how to do it? Is there anything that Jerry should be aware of that you threw in there or anything so that he can, you know, so the reconciliation could be simpler?
Yeah, we have that in the detail. So when we share it, he'll be able to see it.
He'll be able to see it.
And we
Okay.
tried to be careful to call it, you know, not to blend it with other things so that we can
Okay.
evaluate it. I think it should be pretty self-explanatory.
Okay, good. Because
If
he'll,
he's
you know,
looking for a heads up, it would be, you know, 5 to 6 feet of depth of underpinning of the existing foundation underneath
okay,
the perimeter wall down to what we believe to be the bearing elevation. So that's about 900 square feet of underpinning, and then supportive excavation around the perimeter to allow, down to a depth of 10, 12 feet for the overex, and trying to be conservative there, because as I did hear the comments from the test pit of the current corner, we don't know if it gets worse or better, but when we're there, I guarantee that the recommendation from PAR will be keep going till I get to suitable.
Of course. Okay. And then what about the
that'll be in
watering?
and that'll be in the water table. So
Okay.
Water table, the dewatering won't be insignificant, and I think we're going to have to do something with the supportive excavation and just from the soils information, it seemed like the unsuitable was the high silt content, but yet the rest of it with gravel and sand permeable. I expect that if the water table is high, that it will run, and we'll have some continuous pumping.
Continuous pumping.
And on-site treatment of that, right?
Yes.
Yes.
Okay. All right. All right.
It's a risk that if we can avoid, it doesn't make sense to embrace.
Yeah. That's a great way to put it, Greg. That was very eloquent.
Okay. All right. Simon or Wesley, do you have any questions for anybody right now? Bond, Wesley specifically, because you guys have had a lot of conversation here.
I think in terms of my end, I think I'll get back to you with how many piles I need below each column. And I'm going to be using the 35 as my base point for now, the 35-ton capacity as my base point. Yep. I don't have any other questions.
Okay, great. Thank you.
And I think
Simon?
I'm all set for now. I'm all set. Thank you.
Okay. Awesome.
Okay. Okay, thanks, guys. So in terms of next meeting, so some of us are going to get the estimates on Friday. We're going to do a reconciliation on Wednesday. Reconciliation on Monday. Hopefully get the final back by Wednesday to present to the committee on Thursday of next week, and then depending on how we do next week, we'll schedule another working group meeting. We did do the walkthrough yesterday, so I think David and Greg and Dario and Mike are going to start looking at some phasing and logistics. So probably another 2 weeks before this group needs to meet as an advisory group again.
Okay. Yeah, I'll have to talk to the team about the schedule because, the decision process for the foundations is huge for Wesley. I'm speaking for you, Wesley, here, but I'm going to say that because he needs like a go or no go. Is it piles? It's one thing, and if it's foundation, it's another. So he can.
I don't want to design the building twice.
Yeah, he can't divide it twice.
I think coming out of that building committee meeting when we have the numbers in our hand. So by the end of next week, we'll either have a decision or we'll be having another meeting with this group again.
Yeah. Okay.
On Monday or Tuesday. So
okay.
We'll get that quickly.
Yeah, agreed. So Wesley he could the only thing he can really design probably right now is the entry points. And that's pretty limiting to start on a small piece without doing the comprehensive, in my opinion. So okay, great. Thank you.
All right. Thank you, guys.
Okay.
Thank you.
All right. Thanks, everyone.